This lecture is an introduction to the replication system of Unreal. It's an overview of the various different parts of the system, and it introduces you to the most important parts. It will give you a solid foundation of knowledge so that once we start using this inside of our project, it will all make sense to you. Okay then, let's start with the basics. Once a multiplayer game is running, Unreal's replication system starts working behind the scenes to make sure all the different instances of the game are in sync. Each computer builds their own version of the shared game world, so the replication system makes sure all of them agree on what is happening in that world. The server holds a list of connections for each connected client. A channel is used to send data to the clients. An actor channel is created for each actor that is said to be replicated. So the server has a list of connections for each of the clients, and it creates a channel to send data to those clients. And among those channels, there are actor channels for each actor that is said to be replicated. This tells us that replication is happening on the level of actors. If you need an actor to stay in sync over the network, you need to configure that actor to be replicated. But how do you do that? You do it by setting the beReplicates variable in C++ to true, or you need to set the replicate setting of an actor blueprint to true. By default, most actors don't have replication enabled, so they will only work locally. So if you want something to be replicated, we need to do it ourselves. Once you set the beReplicates variable to true, Unreal's replication system will pick it up, and the server will create an actor channel for that actor in order to share data from the server to the client to keep that actor in sync with the server. So the following are the common replication features Unreal offers that we're going to use. This list isn't exhaustive, there are more, but these are just the ones that we're going to use most often. Creation and destruction, movement replication, variable replication, and remote procedure calls, also known as RPCs. Creation and destruction has to do with actors being spawned and destroyed. Movement replication has to do with the location of actors. Variable replication has to do with variables being replicated, as the name suggests, and RPCs are functions that can be called from one machine in the network and executed on another machine. Now we're going to go one by one and explain these in more detail. Creation and destruction. When a replicated actor is spawned on the server, it will automatically generate remote proxies of itself on all connected clients. So basically, if you spawn a replicated actor on the server, it will also spawn copies of itself on the connected clients. Let's take a look at this example. We have the server and the client. The server spawns a box actor. So this is an actor that is spawned on the server. Once the server does that, it will automatically instruct the client to do the same thing. And the client will also spawn a box actor in its own world. This is very important because when the server spawned a box actor, the server's world, game world, is now different than the client's. So we immediately need to tell the client to do the same thing in order to keep the different game worlds of the server and the client in sync. And likewise, when the server destroys its box actor, it will immediately tell the client to do the same thing, because currently the server has no box actor, but the client has one. So immediately it will tell the client, destroy the box actor, and the client will do so. So the lifetime of a replicated actor, this box actor has to be replicated for this to work. It has to have that beReplicated variable set to true. The lifetime of a replicated actor is replicated from the server to the client. Once it's created, it's also created in the clients. Once it's destroyed on the server, it's also destroyed for the clients. And the key point here is that you need to do this from the server. If you spawn a replicated actor on the client, then this isn't going to work. It has to happen on the server. Same with destroying. So this tells you that you should always spawn these replicated actors from the server. If you spawn something on the client, and let's say that you have other clients connected to the game, that client that spawned the actor will be the only client with that actor. And that means that client's game world is different than the server and different than the other clients. And that's a problem. We always want to make sure that all the clients and the server agree on what's happening in the world. This creation and destruction is handled by Unreal automatically, so we don't have to do anything extra. Once you spawn an actor that is replicated on the server, this will automatically happen. And once you destroy a replicated actor, it will also automatically happen. You just need to understand how this works. Movement replication. If an authoritative actor has replicate movement enabled, or the bReplicate movement variable set to true in C++, it will automatically replicate its location, rotation, and velocity. So this is very self-explanatory. To really demonstrate this, let's take a look at an example. Here I have a blueprint class that I just created. It has a static mesh of a cube and nothing else. If you take a look at the details pane, we have some settings for replication. You can see that we have replicates. If you turn this on, this blueprint actor will be replicated. We also have replicate movement. If you turn this on, then the location, rotation, and the velocity of the blueprint actor will be replicated as well. Let's test the game with these off, and then we'll come back and turn them on and see the difference. So here I have the blueprint class in the game, and I'm gonna run the game as a listen server with 2 players. From the client, let's start playing with the box, let's start pushing it around, and immediately you will see that the location is now different from the client compared to the server. On the client it's right here, but on the server it's still on the ramp. So this is clearly not correct, and we don't want this in the game. So let's go back into the blueprint class and set the replicates and replicate movement on. These both have to be on for this to work. You can't just turn on replicate movement, you also need replicates to be turned on. Let's compile and run the game again. And this time we can play with the box as much as we want, and the location, rotation, velocity will always be the same because replicate movement is turned on. And you can see that as much as I play with this, it is still the same. So that's movement replication. This is also automatically taking care of Unreal for us. We just need to set bReplicate movement to true as well as bReplicates, and then Unreal will take care of replicating the location, the rotation, and the velocity. Just like creation and destruction, movement replication, you just need to understand how it works and enable it. Next up we have variable replication. This is very important. Any variables that are designated as being replicated will automatically replicate from the authoritative actor to its remote proxies whenever their values changed. Okay, so let's take a look at this example. On the left hand side here we have the server. Server has a box actor spawned in its world, and this box actor has a variable called bExploded. And likewise, the client also has this actor with the same variable. This actor is replicated, of course, and the bExploded variable is set to be replicated as well. This is a variable that is defined in the box actors C++ class, and it's set to be replicated. Once you change this variable on the server, so let's say that the variable is set to true now, the server will immediately instruct the client to do the same change to its own box actor's bExploded variable. So this is how variable replication works basically. It's simple. If a replicated variable is changed on the server, that change will be replicated to the client in order to keep the variable, keep the 2 different actors, one on the client, one on the server, in sync. And the word remote proxy here just means the copy of the actor, the authoritative actor, that is on the client. So on the server is the authoritative version of the game, and this box actor here is the authoritative version of this actor. The game is also running on the client, and the same actor is also spawned on the client, but this one is simply the remote proxy of the authoritative version of the actor that is on the server. It's basically the copy of it that's on the client. Okay, finally we have remote procedure calls, or RPCs. These are special functions that are transmitted to specific machines in a network game. So these are called from one machine in the network, but executed on a different machine. No matter what machine an RPC is initially called on, its implementation will run only on the machine it is intended for. So it can be a function that's called on the server, but it's only run on a specific client, or it's called from the client and run on the server. That's what an RPC is. We have three different types of RPCs. A server RPC, which only runs on the server and it's called from the client. A client RPC, which is only run on clients, but it's called from the server. And finally, a net multicast RPC. This one runs on every machine that is connected to the session. Let's take a look at how multicast RPCs work. Now, in this lecture, we don't have time to dive into each type of RPCs, and like I said, we're going to learn more about them in the future. So this is just an explanation of one type of it to see how it works. So we have the server here. The server has the box actor, and we have three clients connected to the server, and they also have their own box actors. And this box actor has a function that is declared as a multicast RPC, and it's called multicast RPC underscore box explode. Once this function is called on the server will instruct all the clients to call the same function on their own copy of the box actor. So this is how a multicast RPC works. You call it from the server, and it's executed on all of the clients as well. So all the machines connected to the game get the function call. That's going to be all for this lecture. Thank you for watching, and we'll continue on the next one.